Hello, everybody. My name is Devin Wanger, and this is my Capstone project. For the past 4 years, I have been working on two exoskeleton prototypes, a upper body exoskeleton and a lower body exoskeleton. I did this in collaboration with a team on campus called MStarks, which is Michigan's exoskeleton design team. And again, I've worked on this team for the past 4 years, and last year I led all the projects as president. So I'd like to give a little bit of an introduction on this project. We have set out to help two different types of people. The first type are first responders who have to do their job. They have to carry, for example, firefighters have to carry around 70 pounds of gear on their back in order to go into a burning building to save people. And unfortunately, this will slow them down because it's such a heavy weight that they have to carry while doing pretty intensive work. So if we can build an exoskeleton that helps alleviate that weight for them, they're going to be able to do their job better and save more lives. The other group of people we set out to help are people who work in factories or warehouses. They have to typically carry really heavy loads all day for really long periods of time. And this, over long-term years, can cause joint damage, which then will put them out of work, causing a financial strain on them and their family, and also a financial strain on the companies they work for, because they will likely have to compensate them for their injuries. So if we can create an exoskeleton that prevents that from happening, we can help a lot of people. To investigate this, we created two different exoskeletons. Our first one is a upper body exoskeleton. This one was designed to use pneumatic muscles to increase what you can curl by around with your bicep by around 45 pounds. We built a frame around these pneumatic muscles, which contract as air is supplied to them, and they're controlled through myoelectric sensors that are attached to the user's bicep. And when they detect an electric signal from the user flexing their muscle, the regulator and air tank in the back will supply a pressure to the pneumatic muscles that causes them to contract, decrease in length, and the mechanical arm to move up. Our second exoskeleton design is our modular legs exoskeleton. It's modular. Really, the modular nature of it comes from its ability to adjust to accommodate users of multiple heights. And this one works a bit differently. This one has a motor at the hip and knee, which, when you take a step, essentially provide a counter force to counteract the weight that you have on your back. And this can increase what you carry on your back by around 75 pounds. In addition, there's also a spring system at the ankle that will push up every time you take a step, further countering that weight. And we have discovered that using that, one of the biggest things to help with these lower leg exoskeletons, most of them can support this heavy weight, but sometimes they will actually make the user more tired while using them instead of making them less tired. So a big thing we've been trying to investigate with this exoskeleton is making it more what it's called metabolically efficient, which means you want to be less tired while wearing the exoskeleton than not wearing it. So we've done a few things to approach this. The first one is making the exoskeleton very lightweight. We've been using lightweight materials such as aluminum, and we've been looking into carbon fiber. Another way we've been doing this is through certain attachments. So the exoskeleton has to find a balance between fitting tightly and not too tight so it doesn't restrict your movement. And so we use different sports pads and straps to ensure that could happen. And the last thing we've been doing, which we plan on working on more in the future, this is a little bit halted due to COVID, is implementing a machine learning algorithm that can map the user's gait cycle. So everybody walks a little bit differently. So what we're trying to do is basically have our exoskeleton learn how the user walks, so then it can follow them better, and you won't really be fighting it while walking it. So that's what we've been working on. We plan on progressing further in the future. Of course, unfortunately, COVID has slowed us down a little bit, but we've made good progress this year. We've worked on eliminating some, like in the future also with Sammy, we hope to eliminate some noise from the myoelectric sensors, and further improve the frame that's the pneumatic muscles are on. And again, with Lexo in the future, we hope to implement the machine learning algorithm, make it more lightweight, and improve the ergonomics a bit. And so that pretty much concludes this part of my presentation. I would also like to thank our faculty advisor, Professor Elliot Rouse. I'd also like to thank our sponsors, which were Boeing, the Electrical Computer Engineering Department of Michigan, the Mechanical Engineering Department of Michigan, and the Robotics Institute of Michigan. And now I would like to take some time to answer some of the questions I was asked at Design Expo. So the first question I got was how I got involved in this project. So I got involved in this project the second semester of my freshman year. And really, so if you're interested in joining MStarks, they're a campus run organization that is very open to having new members. I joined as a freshman. I've worked for the past 4 years on the team. Really the reason I got into this project is just because I've always had a pretty big interest in exoskeletons, and I wanted to sort of help contribute to that field really since I was like a freshman. And so another question I got from Design Expo is about what inspired me. So really what inspired me to join this team, to sort of work on this team, is just a general interest. I mean, I've always found exoskeletons very interesting. I mean, like you see movies like Iron Man or like Elysium, and you see stuff like that, and you really, aside from those really cool factors, there's this almost like this ability to allow machines to help people particularly with exoskeletons, that I think is really interesting. And that's kind of what like the science fiction cool aspects combined with that ability to help people is kind of what draws me to working with them. And finally, how did I connect with my Capstone advisor, lab, and team? Again, really, I just went to, this is the final question, I really just went to Winterfest and I was able to connect with the team and my Capstone advisor kind of through that. And so that pretty much concludes my presentation. So thank you for listening. Thank you for listening.